Our second example of doing a Lagrange multiplier question is much more typical of the kinds of things that can happen. There's going to be some twistiness in the middle, and when we're all done, the oh crap list actually will become very relevant. Meanwhile, we know how to start. We're supposed to write down the gradient of f equals lambda times the gradient of g. We know how to find the gradient of f. It's partial x, that's 2x, partial y, that's 2y, partial z, that's 2z. That's supposed to be equal to lambda. Now let's see, partial with respect to x is y, partial with respect to y is x, partial with respect to z is minus 2z. And then we start writing down all the equations that go along with it. Always a good idea. The first row gives us 2x equals lambda y. The second row gives us 2y equals lambda x. The third one gives us 2z equals lambda times minus 2z. And then the fourth equation is just the constraint equation. So that's xy minus z squared plus 1 equals 0. I'm just going to put a little box. These are the 4 equations and 4 unknowns that we have to solve any way we can. Most books will usually say solve for lambda, so we're going to start solving for lambda. In equation 1, divide both sides by y, and I'm going to get 2x over y. And in order to do that, I assumed y wasn't 0. So over here, on the oh crap list, I'm going to have to worry about later what happens if y equals 0. Now, meanwhile, in the second row, I solve for lambda, and I get 2y over x. Well, in order to get that, I had to divide by x. I assumed x wasn't 0, so later on, I'm going to have to worry about what happens if x equals 0. Meanwhile, I get to the third row. The third row should say lambda is equal to 2z, I'll just write it out, over minus 2z, that's negative 1. So we get lots and lots of little equations to look at. What I'm going to do first is just look at my first 2 equations involving x and y. So what am I going to get here? I'm going to cross multiply. I'm going to get 2x squared equals 2y squared. I'll divide both sides by 2. I'll take square root. I get x equals plus or minus y. Now what am I going to do with that? Well, I'm going to go back down to my lambda equation, and I'm going to use this last part right here, where 2y over x equals minus 1. And I'm going to have to actually break this up into little cases. Case number 1, what happens if x equals y? I mean, I know x equals plus or minus y. What happens if x equals y? Well, I'm going to come down to this equation down here. If x equals y, I'm going to get 2y over y, which is obviously 2, but it's supposed to be equal to minus 1. Okay, that means x equals y can't happen. Right? 2 can't be minus 1. Yay! The second part of this equation said, okay, if x wasn't y, maybe x could be equal to minus y. Well, if x equals minus y, I come back down to this equation again. I'm going to get 2y over minus y, which is clearly minus 2, but it's supposed to be equal to minus 1. Well, it clearly isn't. That means x can't be equal to minus y either. Okay, well, if x can't be minus y and x can't be y, we just start going back up, right? That all came from this equation down here. That meant that 2x over y couldn't possibly be 2y over x. So what happens here, as we see here, this right now has no solutions. In other words, we solved for lambda, we looked at all the equations we could, and we found no solutions. Does that mean that this problem doesn't have a solution? It doesn't mean that. It means that the oh crap list is going to take care of everything. Now, by the way, I forgot, when I looked at equation 3, I divided both sides by z, and I'm also going to have to worry about what happens if z equals 0. So meanwhile, I'm going to come down here. The lambda equation is all going away because it didn't lead to anything good. And what I'm going to have to do, one thing at a time, is try to figure out what happens? Well, the first thing from the oh crap list, let's call this A, and let's call this B, and let's call this C. I think that'll work out. So let's just think what happens in equation A. What happens if y equals 0? Well, now I'm just going to go back to my equations. You can see from equation 1 that if y equals 0, x equals 0. And if x and y are both equal to 0, then equation 4 is going to imply that z equals plus or minus 1. In other words, we get two critical points there. We get 0, 0, 1. We get 0, 0, minus 1. That's what can happen if y equals 0. It actually leads to some points we get to think about. Part B of the oh crap list was x equals 0. If x equals 0, then equation 2 says that y is 0. And then equation 4 says that z is equal to plus or minus 1. Well, we already have all those, so that didn't actually add anything new. The only thing I have left to worry about is what happens if z equals 0. This is actually a lot of work. I'm just going to look at my 4 equations. What happens if z equals 0? We still have equation 1, which is 2x equals lambda y. We still have 2y equals lambda x. The third equation just turns into 0 equals 0, which is always true, so I'm just going to leave that off for the moment. And then I have 3, I have xy plus 1 equals 0. Now what is this? This is unfortunately a mini Lagrange multiplier question inside a much bigger Lagrange multiplier question, and we're going to have to start solving it the same way. In other words, for our mini Lagrange multiplier question with just these 3 equations, I start solving for lambda. I get lambda equals 2x over y. Now, I just assumed y equals 0, but I've already used up my oh crap list. So what I'm going to have over here is oh crap junior. Yeah, that's it. How if we call this D? What happens if y equals 0? Meanwhile, in equation 2, I divide by x, I get 2y over x. And in oh crap junior, I have to worry about what happens if x equals 0. But that's it. So what I'm going to do is just look at this little piece right here, and I'm going to solve the same way I did before. We're going to wind up with x equals plus or minus y, which before led to some contradictions. What happens here if, for example, x equals y? If x equals y here, x equals y, I'm going to look at equation 3 now, and I'm going to get x squared plus 1 equals 0. Well, that has no solutions. I didn't get any contradictions here, but I did get no solutions. All right, what happens if x equals minus y? If x equals minus y, and I go back to equation 3, I'm going to get minus x squared plus 1 equals 0. I pull out a negative 1, and then I factor, and I get that. So I will either get x equals 1 or x equals negative 1. But then y is negative x, so I'm going to get y is negative 1 for this piece. Make sure I can try to read that, because we're going to have to make a table later. And then y equals 1 is this piece. Let's see here. In our mini Lagrange multiplier question, we made an oh crap junior list. We still figured out that x equals plus or minus y, but we actually have 2 more points to have to worry about. I am going to put them someplace. Where do I want to put them? How about over here? We already have the point 0, 0, 1 from a long time ago. We have the point 0, 0, minus 1 from a long time ago. We have 1, minus 1, and z equals 0. And we have minus 1, 1, z equals 0 like that. And the only thing we have left to do inside of our mini Lagrange multiplier question is start worrying about the oh crap junior list. So let's worry about the oh crap junior list. And then we're going to look at item D. Item D says in oh crap junior, what happens if y equals 0? We're just dealing with this mini Lagrange multiplier question right here. If y equals 0, then equation 1 says that x equals 0. That means we're looking at the point 0, 0, 0, which doesn't work with equation 4. What does that say? That says in our mini Lagrange multiplier question, y can't be 0. So we'll cross it off. We've taken care of that much of oh crap junior. The last part of oh crap junior says, this is, let's see here, y equals 0. That should have been, yeah, that's D, that's right. And this is E. What happens if x equals 0? Come on, you get straight. If x equals 0, going back up here to oh crap junior, then 2 says that y equals 0. But that means we're at the point 0, 0, 0, which is again not allowed. So we've already taken care of that. So what it means, assuming that x, y, and z all weren't 0, we didn't get any points at all. Right? And then we started going through the oh crap list, and we got the point 0, 0, 1, 0, 0, minus 1. But when we got to the part C of the oh crap list, we wound up creating a mini Lagrange multiplier question in the middle, and we got 2 more points, 1, minus 1, 0, and minus 1, 1, 0, like this. But we still haven't figured out which one gives the maximum value, which one gives the minimum value, but we now know that the maximum and minimum value all has to happen right here. And so what I'm going to do is wipe out the stuff that no longer matters. And all we have to do now is finish the problem. How do we finish the problem? Well, we know that our function, which is x squared plus y squared plus z squared, yes, x squared plus y squared plus z squared, has to have a maximum or minimum at these 3 values. So all I'm going to do is make a little table. So I have x, and y, and z, and the function. And we have 4 points to worry about, right? We have 0, 0, 1. We have 0, 0, minus 1. We have minus 1, 1, 0. And we have 1, minus 1, 0, like that. And we just start plugging in. 0 squared plus 0 squared plus 1 squared is 1. 0 squared plus 0 squared plus minus 1 squared is 1. Minus 1 squared plus 1 squared is 2. 1 squared plus minus 1 squared is 2, right? And what does that give us? It says there are 2 minimum values and 2 maximum values. So the table says this is the smallest that function can possibly be on the surface x, y, minus z squared plus 1. And there's another point with the same value. There are 2 points that have the maximum value. And we're finally done with this problem.